Hey everybody, Miss Null here. I'm going to do a quick video or two on z-tests for proportions and a z and a t-test for means. So the means videos might go to a separate video. So here we go in proportions. So if you were doing a one sample z-test for a proportion, remember proportions, population proportions we call p, sample proportions we call p hat. And I'm going to kind of go over the state plan do process for these, but depending on how the question's asked, maybe you're asked for hypotheses, and then in part A and part B might be the plan, and so on. So I don't think on this year's exam you'll have to worry so much about the state plan do, but it does help go through the process. So if it was a state plan do, we would state the hypotheses first and define parameters. So my hypotheses, remember, is the ho and the ha. So for proportions from the intro video I posted the other day, that'll be p is equal to whatever number they tell you in the problem, whatever decimal they tell you the population is known to be. And then the ha, the alternative hypothesis, is going to be that p is either less than, greater than, some inequality. I'm just going to use not equal to for the purposes of the video, some number. So we'll state those hypotheses in the state. Oh, and then parameters, we'd say what that p means. So we'd say something like where p equals the true proportion of whatever. So whatever the problem's about, p is the true proportion. Eventually, we're going to do two proportions. So you'd have to say p1 is this proportion, p2 is this proportion. So again, the state, we put our ho and our ha, and then we'd list what that parameter p means in context of the problem. Plan, choose an appropriate inference method and check conditions. Our conditions here are random, independent, and normal, or the 10%. We've kind of been calling it 10%. And normal condition. The random condition is just that we must pick the sample at random. So they'll usually say SRS or something sort of speak that is random. 10% is the sample size must be less than 10% of the population. And normal is NP and NQ must both be at least 10. So nothing new with those conditions. We've seen them before. And then if conditions are met, there's two ways we can go about the do. So the first way we can do the do is calculate this test statistic. So here, that'll be a p hat for us. So we'll be given some sample statistic to see, well, how unusual if that p is true. And then finding the p-value, we're going to have our p in the middle. And then our p hat, depending where it is, will be labeled next to it. That's our p hat. And then depending on the inequality, we're going to shade. So really, if it was like the one we did in my hypotheses, there would be a two-tailed test based on some p hat. But we'd find that probability, so those shaded areas. There's another way I'm going to show you in the calculator. If I go to Menu, Statistics, Stat Tests, and then I should see a one prop z-test. Here, this is the p0. That means the proportion from the null hypothesis. So that little zero, or that zero, represents the p from the null. Here is my p hat, success over total. Okay, that's where p hat comes from, and then you pick your alternative. So that's another way to find this, and I'm going to go through both ways in an example. Let me go back to the notes. And then conclude, we're going to interpret. So based on that p-value, are we going to reject the null hypothesis, meaning we got a small p-value? Or are we going to fail to reject the null hypothesis, meaning we got a large p-value? And of course, we'll add that in context. And then here's kind of what I'm talking about with this picture of this normal curve. And I mentioned, before I move on to the example, I mentioned for the past couple of weeks that confidence intervals and what we're doing now with these stat tests are all based on these sampling distributions. So mu p hat, sigma p hat, that's not new to us. That's the sampling distribution for proportions. All right, here's an example about potatoes. A potato chip producer has just received a truckload of potatoes from its main supplier. If the producer determines that more than 8% of the potatoes have blemishes, the truck will be sent away to get another load from the supplier. A supervisor selects a random sample of 500 potatoes. An inspection reveals that 47 of them have blemishes. Carry out a significance test at the alpha equal to 0.10 significance level. What should the producer conclude? So for this state, we're going to mention the significance level and then state our hypotheses. So they told us in the problem, we're going to perform a test at the 0.1 significance level. And we're going to look for the hypotheses, the null hypothesis. Let me get a highlighter tool. So for my null hypothesis, we're going to assume that they're 8%. The alternative is going to be the more than 8%. So everything's based off of this 8%. So if I scroll and show you my hypotheses, so here the null is that it equals 8%. Some books will use a less than or equal to or the opposite of the other symbol, but we're fine with just equal. So we're going to assume that the number or the proportion of blemished potatoes is 0.08 or 8%. And the alternative is we wanted to see, is there actually more than 8%? Or is the proportion greater than 0.08? And then we also need to define what that P means. And here P is the actual proportion of potatoes that are blemished. And that's it for the state. Now the plan, we're going to check the conditions for a one sample z-test. And the conditions are really the same as a sampling distribution, but we have that random condition involved. So random, we're told up here that the sample was chosen at random. 10%. I'd assume 500 potatoes in a truck is less than maybe 10%. 5,000 potatoes in a truck, that seems to be definitely less than 10%. You can fit more than 5,000 potatoes in a truck. So there's my random. Normal, so my answers here out of order from my brain, but normal condition, NP and NQ. So to check this, you'd have to show this and write it out. I'm going to scroll to it, but NP, so here's N, 500, times P, 0.08. Is that greater than 10? Well, yes, it is. And NQ, so 500 times 0.92, those are both greater than or equal to 10. So you see that here. So 500 times 0.08 is 40. That meets the requirement. NQ, 500 times 0.92, that's 460. That meets the requirement. And then we already checked the independent condition. So now we're on to the do, and I'm gonna answer to the next page. That's good. So because I want to show the do two different ways. So let me get rid of. All right, I'm gonna show you the do two different ways. So one way we can do the do is kind of the way we've been doing probabilities with sampling distributions. So here, the mean of the sampling distribution, we already know it's normal. Remember, we checked this normal condition. But the mean is going to be the same as the population proportion, which here we're assuming is 0.08. The standard deviation of the p-hats, I'm going to bring up my calculator and pause the video, but that's the square root of PQ over N. Let me see what that decimal is. All right, so I calculated that standard deviation real quick, and it rounds to 0.012. So if we think back when we did this before, we'd sketch our normal curve. My center is the mean, so that's 0.08. And then if you look for my sample proportion, the p-hat from the problem, that was 47 out of the 500. So this is from the original problem. So 47 in that sample had blemished potatoes. As a decimal, that's 0.094. I did that calculation as well. So 0.094 is up here somewhere. And our alternative was greater. So we're interested, is the proportion greater? So based on this sample, how likely is it to get this shaded area? And that's an easy calculation to find. I just do a norm CDF. So remember, a norm CDF, my lower bound is going to be this 0.094, my upper bound's infinity, and then the mean is the 0.08, and the standard deviation is this 0.012 that we calculated. And if I do that, I did it here a little bit ago, I get 0.122 about. So 0, that shaded area is 122. That's that shaded area. So that's one way to do the problem. The other way to do the problem, let me go back to my calculator, is a one prop z-test. So menu, statistics, stat tests. I'm going to pick one prop z-test. The null hypothesis proportion was 0.08. In my sample, my successes were 47 out of the 500. And I want a greater than. And if you look, here's my p-value. Not exactly the same, but very, very close. Let me just paste this on that notes page just so you can see it side by side. So here is my calculation from the calculator. Very close to the same, 1.22 or 0.122 is very, very close to 0.124. Concludes going to be the same. That p-value is large. That's not a small proportion, or that's not a small probability, sorry. That's a high probability, specifically 0.12 is higher than our 0.10 significance level. Okay, so we're going to end up failing to reject the null hypothesis. And the work, either way you do it is fine. I mean, you could do old school like we did with the sampling distributions, like in my drawings, or we could do the new way with the cheat and the calculator. Either way is fine, maybe a little bit less work with the calculator, but the old way is fine because we're used to it. And then my conclude, so our p-value, and look, the textbook got a little bit different p-value because they rounded. It's all with rounding. It usually won't be enough of a difference in the methods to get a different conclude. So regardless, our p-value, we got 0.122 and we got 0.124, I think. Either case, they're greater than the significance level of 0.10, so we fail to reject the null hypothesis. And we conclude in context, there is not sufficient evidence to conclude the shipment contains more than 8% blemished potatoes. And then I'm running out of my 15-minute time limit here. I only got 3 minutes left. So I'm just going to quickly go through a two-sided test and how it's a little bit different but similar to the one-sided test. So this is 50% of high school students have never smoked cigarettes. Taeyeon wonders whether this national result holds true for his large urban high school. For his AP Stats class project, he surveys an SRS of 150 students and gets responses from all of them. 90 say they have never smoked a cigarette. What should Taeyeon conclude? Now here, they didn't give us a significance level, so you could pick one. So whoever did this problem, I think it was me a long time ago, I chose to do it the 0.5 significance level. That's just a common one. You know, I've mentioned it before in class. Maybe it's my favorite significance level. But I'm going to decide on my p-value based on how, is it smaller or bigger than 0.05? Now, notice the hypotheses are a little bit different. So my hypotheses here, the null is still what it's known to be. So they say 50% is what the proportion is known to be. So the null hypothesis, p equals 0.5. Then the alternative is Taeyeon. He wonders if it holds true. Is it the same or is it different? So if you see different or anything indicating different, it's going to be a not equal to in the alternative. And what that means for our test, if we go to calculate a p-value, we're going to calculate two tails. We're going to see, well, this plus this, is it unusual? Let me go to my conditions. So here are my conditions, random, normal, independent. They all are met here. Nothing new with conditions. And then the do, I'm going to show you a do in both ways. All right, I paused the video for a second. I went ahead and made these calculations and drew my picture. So for the do, the p hat here, 90 over 150, because 90 of his classmates said they have never tried cigarettes, divided by 150 is 0.6. The mean of the sampling distribution is the same as the mean of the population. That was 0.5. And then I did square root of PQ over N to get this sigma of P hat. Now, if I go in the calculator, I do a norm CDF, I'm going to get a probability here, but remember, it's a two-tailed test. So whatever I get there, I'm going to multiply it by 2 to include this tail. All right, I'm going to go back to my picture here. I calculated my p-value, did it two ways, but when I did it with norm CDF, I got 0.007. So I'm going to take that number and multiply it by 2. Because there's two tails, I get 0.015 for both tails. which is the same thing if I did the shortcut